Hello friends, welcome to Susan and John MathTube. In today's video, we are going to continue our discussion based on eigenvalues and eigenvectors. In the last two videos, we started learning about characteristic equation, and then in the last video, we learned how to find the eigenvalues and eigenvectors. In today's video, we are going to learn how to find eigenvalues and eigenvectors in all possible cases of eigenvalues. So the first one, so I'll write it over here. So type 1, the eigenvalues are distinct. So please note the question. Find the eigenvalues and eigenvectors for the matrix. So as usual, the first thing, you can give it a name. So write let A is equal to. And as always, I hope you're ready with a pen and paper. So let's start. Now the next thing to do is we have to find the characteristic equation. And in the last video, I told a trick to find that determinant a minus lambda I is equal to 0. It's very easy. All you have to do is look at the leading diagonal elements and subtract lambda. So that will be 4 minus lambda, minus 20, minus 10, and then minus 2, 10, minus lambda, and then 4, then 6, minus 30, and minus 13 minus lambda is equal to 0. And you can start expanding the determinant like we did in the last video. But I told you in the last video that I'll teach you a shortcut today. So let's go for it. Now this shortcut will work properly only if you have a calculator. So the first thing to do, we'll find something called S1. S1 means the trace of the determinant or the trace of the matrix. Trace simply means the sum of all the diagonals, the leading diagonals. So that will be 4 plus 10 plus minus 13, and that will be 14 minus 13, that is equal to 1. So I will note it somewhere here. S1 is equal to 1. Now the second one is S2. For S2 also, you have to look at the leading diagonal. So take a look at 4. Now I want you to leave that row and that column. So are you able to see a determinant? So let's note that determinant. If you practice a lot, then you don't have to write the determinant. You can do it directly. And then plus. The next thing, you take a look at the next element in the leading diagonal, that is 10. Now you can leave this row and this column. So I hope you can read the remaining elements. So that will be 4 minus 10, 6 and minus 13. Plus, now what we do is we take a look at the last element. Now you can forget about this and this. So that will be 4 minus 20 and minus 2 and 10. Okay, so let's expand this. That will be minus 130 plus 120 plus, what is 4 into 13? Yeah, that will be minus 52 plus 60, and 40 minus minus minus, that will be minus 40. Okay, so that's gone. Now this will be minus 10, and this is going to give me plus 8. So I'm going to write here S2 is equal to minus 2. So that's very easy. S1 means you add all the elements in the leading diagonal. And what do you call that? The trace. And S2 means you find the minor. I hope you remember the word minor from your +1 or +2 mathematics. Okay, so what we do is we pick out the first element in the leading diagonal and leave that row and that column and find the determinant of the rest. It's a mess now. Okay, so I'll do one thing. I cleaned everything. So we have the matrix and we have S1 and S2. Now the third one, S3. S3 is actually the determinant of the matrix. And you might be thinking it will take a long time to expand the determinant. Okay, it might. So use a calculator. I'll repeat. You can do determinants in your calculator. So I want you to use your calculator and find the determinant, and that is equal to 0. Okay. Now you have to remember this expression. We have a 3 by 3 matrix. So as I told you in the previous video, we are going to get a third degree equation, a cubic equation. And the equation will be lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So all you have to do is substitute. So our answer will be lambda cube minus 1 into lambda square and then minus 2 into lambda minus 0 is equal to 0. Okay, that's it. So lambda comes common. Or you can use the calculator and solve it directly, or you can take lambda common and equate it to 0. Anyway, the values of lambda are 0, 2 and minus 1. So this is one easy method to find the eigenvalues. Now if you don't like this method, just go for the determinant method which we learned in the last video. Okay, so let's move forward. So we have the eigenvalues, and the first eigenvalue is 0, and the second one 2, and the third one minus 1. And our matrix, I hope you didn't forget our matrix. Okay, now time to find the eigenvector. And once more I'll show you how it comes. So A is the transformation matrix or the transforming matrix, and let X be our eigenvector. The specialty of eigenvector is even after the transformation it will retain its direction, but the length might change, and the change in length is lambda, or the change in scale is lambda, and the vector will be called eigenvector. And if you take everything to the left hand side, it simplifies into a minus lambda I of x is equal to 0, a homogeneous system. This is a homogeneous system because the right side is equal to 0. And we are trying to find capital X and lambda. Lambda we already found. The possible values of lambda are 0, 2, minus 1. What we did is, since it's a homogeneous system, we know that the trivial solution is x equal to 0. So for non-trivial solutions or for infinite solution, we equated the determinant to 0, and that is our characteristic equation. Anyway, we already found lambda, and that's the theory behind it. Okay, so let's start and let's write case 1. So in case 1, we put lambda equal to 0. So the characteristic equation becomes a minus 0i into x is equal to 0. So a minus 0i means the diagonals will remain the same. So the equation changes into 4 minus 20 minus 10 minus 2, 10, 4 and 6 minus 30 minus 13. and let the required eigenvector be x1, x2, x3, and that will be equal to 0, 0, 0. Okay. Now, I forgot to tell you one important thing. I told you this is type 1. In type 1, all the eigenvectors will be distinct. Look at the eigenvectors. One is 0, one is 2, and another is -1. All are different. Okay. And in this case, it's very easy to find the eigenvectors. So the easiest method is rule of cross multiplication. The easiest method is rule of cross multiplication. So what we do is we will select any two rows you like, and I'm going for the second and the third row, and I'm going to use rule of cross multiplication. That is x1 by, you leave the first column, so I'm going to write the determinant 10, 4, minus 30 minus 13 is equal to x2 by, don't forget this negative, now leave the middle column, so minus 2, 4, 6 minus 13, that will be equal to x3 the whole divided by determinant. Now leave the last column, so that's going to give you minus 2, 10, 6 and minus 30. And you can call it is equal to k. Okay, so let's simplify this. So x1 by, that will be minus 130 plus 120, so that will give me minus 10 is equal to x2 the whole divided by 26 minus 24, and there is a negative outside, so that's going to give me minus 2, and that's equal to x3 by, wow, that's cool, 0 is equal to k. Now equate this and this, and then this and then this. So I'm going to get x1 is equal to minus 10k, x2 is equal to minus 2k, and x3 is equal to 0. So the required eigenvector is equal to, so the required eigenvector capital X1 is equal to minus 10k, minus 2k and 0. Now let's put it in the simplest form. That will be equal to, let's divide throughout by minus 2k, so that gives me 5 and 1 and 0. So look at this. Our eigenvector is a system. It's a system of translation vectors. So all the required vectors will be parallel to 5, 1, 0. So I'll repeat once more. So our eigenvectors for lambda equal to 0 will be parallel to 5, 1, 0. Anyway, you can write x1 equal to 5, 1, 0. Now let's go for case number 2. So case 2, I'm going to take a few things from the last page. Yeah, lambda is equal to 2. What's the characteristic equation? I hope you remember the equation. A minus lambda I of x is equal to 0. And now the value of lambda is 2, so I'm going to substitute 2 into x equal to 0. And I told you it's very easy to do. All you have to do is look at the leading diagonal elements and subtract 2. So 4 minus 2, that is 2, minus 20, minus 10, and minus 2. Now 10 minus 2, that's going to give me 8 and 4, and then 6 minus 30 and minus 15. And as always, I'm going to assume my eigenvector to be x1, x2, x3 is equal to 0. Now remember, we are 100% sure we will get infinite solution. This is the homogeneous system, but we chose lambda in such a way that we will always get infinite solution. Okay, so what we do is we can choose any two rows you like. Anyway, I'm going to for the second and the third as usual, and I'll apply rule of cross multiplication. So x1 by determinant of 8, 4, minus 30 and minus 15, and that is equal to x2 by, I'll repeat, don't forget this negative, determinant minus 2, 4, 6 and minus 15, and that is equal to x3 the whole divided by minus 2, 8, 6 and minus 30, and let it be equal to k. So x1 whole divided by, that is 8 into minus 15. If you want, you can use a calculator. So 30 into 4, that will be 120. 120 minus 120, so that will be 0. Now is equal to x2 the whole divided by, this is going to be 30. 30 minus 24, so 6, and that is minus 6 is equal to x3 the whole divided by 60. 60 minus 8 into 6, 48, so that will be 12 is equal to k. Okay, so I'm going to write my eigenvector, the second eigenvector to be, now I'm going to write directly 0, minus 6k and 12k, and let's divide throughout by the common factor. So I'm going to write 0, 1 and minus 2. If you don't wish to divide by minus 6k, you can divide by 6k, because it's just a system of parallel vectors. So there goes our second eigenvector. So the system parallel to the vector 0, 1, minus 2. So case 3, so we have our matrix here, and let's go for the last value of lambda. Lambda is equal to, let's check it. Yeah, lambda is equal to minus 1. Okay. Now, as usual, the characteristic equation is a minus lambda I of x is equal to 0. Now let's plug in minus 1. So that will be a plus I into x is equal to 0. So all I have to do is I have to add 1 to the leading diagonal elements. So 4 plus 1, 5. Then the same thing. Then 10 plus 1, 11. Same thing. And minus 13 plus 1, minus 12. And x1, x2, x3. So let's apply rule of cross multiplication as always. So x1 by determinant 11, 4, minus 30 and minus 12. And that will be equal to x2 the whole divided by minus of minus 2, 4, 6 and minus 12. And x3 the whole divided by determinant minus 2, 11, 6 and minus 30, and that will be equal to k. Okay, so I'm going to write directly, but you can show steps in the exam. So that will be 11 into minus 12, that is minus 132 and plus 120, that's going to give me minus 12k, and then yeah, that's good. And finally 60 minus 66, and that will be minus 6k. So x3 is equal to the system of vectors parallel to 2, 0, 1. Okay, that's it. So we found the eigenvectors x1, x2, x3. So remember, this is type 1, and type 1 is very easy. All you have to do is find the characteristic equation and then apply rule of cross multiplication 3 times and find the eigenvectors. Okay, now let's move ahead and try one question in which we get equal roots. It's from a past paper. Okay, so please write the question. Find the eigenvalues and eigenvectors for the matrix. The first thing to do, as always, let the given matrix be A. Okay, next thing to do, you can find determinant A minus lambda I equal to 0. Expand the determinant, simplify, and you'll get the characteristic equation. It's like this. Some people like the determinant method, so you can stick to that method. And in my opinion, the shortcut method is a little bit faster, provided you know how to use your calculator properly. Okay, anyway, I'm going for the shortcut method. So what I do first is I will find S1. And what does S1 stand for? Trace. Trace means sum of all the leading diagonal elements. And that will be minus 2 plus 1 plus 0. And that gives me minus 1. And now the second one, S2. S2 means the minus, sum of the minus along the leading diagonals. So I ignore minus 2 and that row and that column. So I end up with determinant 1 minus 6 minus 2 0. You don't have to write the determinant and waste your time. You can calculate the determinant value in your mind. Plus determinant. Now I'll move here in the leading diagonal in this direction. Now leave this row and this column. So that will be minus 2, minus 3, minus 1, 0 and plus determinant. Now again I'll come here and leave this row and this column. So that gives me minus 2, 2, 2, 1. And let's simplify. So 0 minus 12 plus 0 minus 3 plus minus 2 minus 4. Okay, so we are going to get minus 15 here and then 16, 17 and that will be minus 21. And now use a calculator. I'll repeat again, this method will be efficient only if you use a calculator. So use a calculator and find the determinant value. So the determinant value is nothing but 45. Okay, now this is a 3 by 3 matrix and that means the characteristic equation will be a cubic equation. So I'll do one thing. I'll note down the values of S1, S2, S3 in the next page. So S1 is equal to minus 1 and S2 is equal to minus 21 and S3 the determinant value and that was 45. Now the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. And that is lambda cube plus lambda square and minus 21 lambda minus 45 is equal to 0. I'll repeat once more. This is the characteristic equation. Now you have to solve for lambda. I'm repeating once more. Use a calculator. Don't try to solve these equations without calculator. So lambda will be equal to minus 3, minus 3 and 5. If you have any doubt in using your calculator, please you can ask me in my email ID, or you can contact me in our website, that is www.SJMATHTUBE. Okay, so look at this. This is type 2. I told you in type 1 all the eigenvalues will be distinct, and in type 2 the eigenvalues will repeat, and here 2 eigenvalues repeated. Okay, let's move on to the next page. So I'll copy the matrix A, and the eigenvalues are -3, -3 and 5. Okay, now look at this. So we have repeated value here and the distinct value over here. So I'm going for the distinct value because I know that's easy to calculate. So case 1, lambda is equal to 5. I'll repeat. I'm going for the distinct value or the non-repeating root. And as always, the eigenvector is given by the equation a minus lambda I into x is equal to 0. And that will be, so I had to, that will be a minus 5i into x is equal to 0. And that gives me -2 minus 5, that is -7, 2 minus 3, 2, 1 minus 5, that is -4, -6, and -1, -2, and 0 minus 5, that is -5. And the eigenvector x1, x2, x3 is equal to 0, 0, 0. And choose any 2 rows you like. As always, I prefer the last 2, and I'm going to use rule of cross multiplication. So x1 the whole divided by -4, -6, -2, -5 is equal to x2 the whole divided by minus of 2, -6, -1, -5, and x3 the whole divided by determinant 2, -4, -1, -2 is equal to k. Okay, let's simplify. So this will be 20 minus 12, isn't it? 20 minus 12. So I'm going to write directly. And what is 20 minus 12? That is 8k. And next, this is -10 and -6. That will be, outside there is one more minus, so that gives me 16k. And the last one, that will be -4 and -4, so that is -8k, and that reduces to 1, 2, -1. So look at this. Our eigenvector for the eigenvalue 5 is a system parallel to the vector 1, 2, -1. Okay, now let's move ahead for the next case. When the eigenvalues repeat, so the eigenvalues are lambda is equal to -3, -3, 5. So this is already done. Now the repeated value. So as always, you can write case 2, and lambda is equal to -3, and the equation a minus lambda I of x is equal to 0 will give us the eigenvector, and that is a plus 3I of x is equal to 0, and let's write that equation over here. So I'm supposed to add 3 in the leading diagonal. So minus 2 plus 3, 2 minus 3, and 2, 1 plus 3, that is a 4, minus 6, and minus 1, minus 2, and 0 plus 3, that is 3, and then x1, x2, x3, that is our required vector, and that will be equal to 0, 0, 0. So just, I hope you got the point. We are adding plus 3, minus 2 plus 3, 1 plus 3, and 0 plus 3. Now look at this. When the eigenvalues repeat, the first thing to do is you have to reduce this into echelon form. That is compulsory. So let's reduce this. I'm not going to write these things. So I'm going to write the operation here. R2 changes to R2 minus 2R1. Now 2 minus 2, that gives me 0, and 4 minus 2 times this, okay, again 0, and finally minus 6 minus minus, that will be plus 6, so 0. Actually it's a multiple. Now the last one, minus 1 plus 1, minus 2 plus 2, and 3 minus 3, that is 0. So look at this. This is the reduced system. So x1, x2, x3, and 0, 0, 0. I hope you're very good in solving equations now. So I'm going to write the system x1 plus 2x2 minus 3x3 is equal to 0. We have only one equation and we have 3 unknowns. So it's like the number of unknowns is equal to 3 and rank is equal to 1. So n minus r, that is 3 minus 1 is equal to 2. That means I am allowed to use arbitrary values for 2 unknowns. So I am going to plug in x2 is equal to k and x3 is equal to c. I'll repeat once more. We are solving a homogeneous system. And the first thing to do is you reduce it into echelon form so that we know the truth. Because if you look at this system, we feel as if there are 3 equations. But when you reduce it into the echelon form, we are able to understand there is only one linearly independent equation. But there are 3 unknowns. So n minus r is equal to 2. So we are allowed to assign arbitrary constant for 2 variables. So I am going to let x2 is equal to k and x3 is equal to c, so that x1 will be equal to 3c minus 2k. Okay. So the eigenvector becomes 3c minus 2k and then k and then c. Now look at this. Since there are 2 arbitrary constants, the method is very simple. First we put c is equal to 1 and k is equal to 0. And then we will put c equal to 0 and k is equal to 1, so that we get the 2 linearly independent vectors. So using this value, I will get x2 is equal to, so let's put c equal to 1. So 3 into 1 minus 0. And then k is 0 and c is 1. And the third vector, I'm going to put c equal to 0. So I'm going to get minus 2 and 1 and 0. So look at this. This is how we find the eigenvectors when we have repeated roots. Okay, now I know this video is a little bit long, but there are three different cases. One is the eigenvalues are distinct, and the second one, the eigenvalues, two of them are same and one different. So what will be the last case? Of course, all the eigenvalues are same. So let's go for the last one and write the question. Find the eigenvalues and eigenvectors for the matrix. So we have 2, 0, 1 and 0, 2, minus 1 and 0, 0, 2. So let's start. As always, you have two options. If you want, you can use the shortcut I gave you. Otherwise, find determinant a minus lambda I equated to 0, simplify, simplify and simplify till you get a cubic equation in lambda. Anyway, I'm going for my shortcut. So S1 is trace, and trace means sum of the leading diagonal elements. And that will be 2 plus 2 plus 2. I'm going to write the answer directly, that is 6. And S2 means sum of the minors taken along the leading diagonal. And to be on the safe side, I'm going to write 2 minus 1, 0, 2, because I left the first row and the first column. And now I'll leave the second row and the second column. So I'm going to get 2, 1, 0, 2. And plus the last one, 2, 0, 0, 2. And that will be equal to 2 into 2, 4, 4 minus 0, that's 4, plus 4 plus 4, and that is equal to 12. And the last one, S3, I'll repeat, use a calculator. So determinant A will be, actually there is a shortcut here, this is an upper triangular matrix. I think you have noticed that the lower triangle is 0, so the determinant will be 2 into 2 into 2, that's equal to 8. So the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Again, use a calculator and solve. So the roots are 2, 2, 2. Look at this. This is the last possibility. We have a matrix and we calculated the characteristic equation and we solved the characteristic equation, and the eigenvalues are 2, 2, 2. Okay, so there is no case 1, case 2, case 3. There is only one case, and we are going for the equation to find eigenvector, that is a minus lambda I into the required eigenvector is equal to 0. And that will be a minus 2i of x is equal to 0. And that means my equation will be 0, 0, 1, 0, 0, minus 1 and 0, 0, 0. Okay, into x1, x2, x3 is equal to 0, 0, 0. Okay, I told you whenever the eigenvalue repeats, the first thing to do is put it in echelon form. Put the matrix in echelon form. So there is no element here, so there is one simple operation. R2 changes to R2 plus R1. So that's going to give me 0, 0, 1, 0, 0, minus 1 plus 1, that is 0, and the remaining will be x1, x2, x3, and that will be equal to 0, 0, 0. That is pretty easy. So now I'll write the equation 0x1 plus 0x2 plus 1x3 equal to 0. Now look at this. number of unknowns equal to 3 and rank is equal to number of non-zero rows, that is 1. So n minus r is equal to 2. So I am allowed to use arbitrary constants for two vectors. So I am going to write, let x1 is equal to c and x2 is equal to k. Okay, now what should we do next? Yeah, next we put c equal to 0, k equal to 1, and we get the first vector. That will be, so we got x3 equal to 0, x1 equal to c, and x2 is equal to k. So the vector will be in the form c, k, and 0. Now what to do next? You put c equal to 0 and k equal to 1 and claim the first vector. And then you put k equal to 0 and c equal to 1 and you get the second vector. So the first eigenvector will be c is 0, k is 1, and of course the last one is 0. And the second eigenvector is c is 1, k is 0, and the last is 0. That's it. So in today's video, we learned how to find the characteristic equation using a shortcut, and then we solved 3 different problems. In the first one, the eigenvalues are distinct. In the second one, 2 of the eigenvalues repeated. And in the third one, all the 3 eigenvalues repeated. I hope you liked the video. I hope you're able to understand how to find eigenvalues, characteristic equation, etc. And normally in your examination, they ask this question for 5 marks. So practice a lot of problems. I hope you understood how to find the eigenvectors and eigenvalues, but this one problem will not be sufficient for you. As a student, take any book of your choice and practice a lot. Okay, so I'm going to end the video right now. I'll be back with more videos, and in the next video we'll be going through a very important theorem called Cayley-Hamilton theorem. And till then, bye.